G'day, my name's Scott Hanson. This is my project for SER201, Deakin University. Alright, so the object of this project was to make a simple little game that you can play cat and mouse on another system with. I don't have that other system, so this is all going to be done simulated. But in a nutshell, there's my board, looking pretty stylish. I know, a lot of time and effort went into that. Now, that's the main system. Got a light source, also known as a laser. Two little servo motors there. Battery operated, so there's no external power at all. There's my fly leads to the head of the other system, if I had one. Little umbilical cord here goes across to the hand controller. Ta-da! That was meant to be wireless, but thank you AliExpress for giving me a faulty component, or thank you me for blowing it up. Either way, let's just assume that it was in fact a faulty out of the factory and that it wasn't me. We'll go with that. Sounds good. Alright, so this hand controller here, it's got a little microcontroller in there. That was because, as I said, I wanted it to be wireless. Well, we don't have that, but we do have this fancy looking cord going across. Oh yeah, pretty stylish. Now we'll turn her on. As I said, fully self-contained. It's got its own little power source, those batteries there. Nothing else going on. Those flashing LEDs, they're my debug LEDs, so I can see what state the program's in if I need to. Now, there was a message that flashed up when it boots. I'll get to that later on, but for now, that's where its minimum X and Y positions are, just to save the servos really, because otherwise there ain't much clearance there if she goes any further down, which is a bit crap. Now, what we'll do now is we'll calibrate the X and Y, so using the hand controller, which I haven't turned on yet. Oops, there we go. Look at that, tilting away. Oh, it's fantastic, isn't it? Oh, let's go down again. And over there. It's that point there, we'll call it 0, 0. I do have this set to go pretty slowly because calibration, otherwise it can get a little bit fiddly towards the edges. And I want to get it pretty reasonably spot on where I want it. There we go. And then it goes to the halfway mark for calibration, so you can get both systems to agree that that is in fact 50-50. So once you've got the point calibrated there, and you've agreed that that's where you want it to be, it says select or rand. What that means is you can either select you want to be a cat or a mouse, go random. So I'm going to hit A for select. Oh shit, now that actually shows there that you're a cat or a mouse. I'm going to hit A again. So you go and cat confirm, A again. You're the cat. Hooray, look at that. So, we're still there. Now at this point, it'll be waiting for an input from the other system. Just sitting there waiting for it to say, hey, I'm a cat as well. Wait a second, what's going on? For that to happen, I'm going to plug the laptop in because I don't have another system here. Hello. Right, so now I've got the computer plugged in. You can see over here I've got the serial test program running. Ta-da! I'm sending a calibration message. It's sending a, sorry, I'm a cat message. See there, here's a cat, I'm nothing. Ta-da! So, back over here, we'll say select, I want to be a cat. We'll confirm that. There we go. Now hit A to start. Now over here you'll see he's still a cat, but I'm now a mouse. Even though I selected cat, that's because we both said cat. So we had both set random numbers. He got 83. I got something lower than that. I'm now sending the ready to go message, which I think he meant to, although this program doesn't. But anyway, so we're pretty much ready to start now. If I go back over here and hit A to start, game on. Alright, now, oh, I forgot to hit start over here as well, actually. Start. Right, so the time's gone up there. I'm not setting any time because I don't have to, but I am setting my position data. Now, you'll see over here, it's saying that I'm at currently 83 and 75, going off the side of the board. Better not do that. Right, now, if I get those both in shot, see as I move that around, if I go off the board there, oh, went off the board. Alright. Good, that's what you want. So you'll see over here, game over. Over here we got A to continue, B to restart, laser off grid. Now, I must admit this LCD screen is a little bit crap. That's what that line there through there is. It's not a program error as far as I can tell, it's just that it's a bad part from AliExpress. I love them so. Right, now I'll do this again. I want to try and win the random thing now. So cat A confirm, A to start. Start on this one here. I actually lost the toss, I'm going to be a mouse again, but we'll just demonstrate something. Game on, dude. So, you'll see the time is ticking away on the display. Is it? Now, if I deliberately head towards the cats, I'll just stop there. Oh, I lost. Now, any second now it'll come up. You done got it. Hooray. Alright, now, again, I want to try and win the toss, so still in calibration mode. He wants to be a cat. Confirm that. Right, I lost. Dope. So we'll just demonstrate going out of bounds. Out of bounds. Alright, that'll put us about do us for the gameplay. I do have most things implemented. I don't have the continue functionality in there. I couldn't get that going with the test program. The code is in mine. I'm not sure it's been implemented in the test program though. So anyway, moving on. The game does freeze at the end by accident really. Oops. Anyway, let's move on to the construction thing I guess. So got some buttons here, A and B. Then it's got a bit of debouncing going on. That debouncing happens on the microcontroller inside the hand controller. Basically, I'm just trying to offload as much as I can into the into this microcontroller so that that one over there doesn't do quite as much heavy lifting. This one also interprets the accelerometer I've got in there, so the IMU, and spews data out to the Arduino Nano in there, which then spews it out over this little serial cable. I do have a PCB in there. I got that made in China. Before that one I had, this one from Deakin, but I didn't have quite enough time to pack all the functionality into that I wanted to, so there you go. As far as iterations of the hand controller went, started off with 3D print, which, oops, didn't go so well. Was enough for testing though. Designed one up in CAD, Inventor actually, and tested on a mate's laser cutter. Then got one made properly at Deakin. Ta-da! Yeah, that's actually turned out really well. I'm pretty happy with that. Yeah, that's pretty solid. You can take the little battery cover here off. So if you just... need 2 fingers for that. Yeah, if I take that out, can access the battery pretty easy. That bit there I can get to, but why bother? Yeah. So yeah, really, as far as the process of designing it, it's been, well, 3D print, cut out and chipboard, or whatever that is, wood of some description. Then the Perspex, acrylic PMMA, whatever you want to call it. As far as this thing, it's got its own little box as well, rather obviously. Now for that, I started with a whole lot of breadboards, moved on to getting some PCBs made up from China. They were amazingly cheap. Here's an example of one that I had before. Didn't have the right chip on in there, but I managed to burn one of the traces, so oops, a daisy. So yeah, so in here, you've got, there's your Arduino Mega battery pack, you've got the PCB I just described, on off switch, dump. There's an LCD display. Try to keep the cabling fairly neat where I can. I've also glued the hell out of everything so that it doesn't move. Not sure if you can see that there. Now, the lid does come off. Yeah, so I've glued the cables down in place there, so they're fairly well locked in. There's a buzzer over there, that's that annoying noise you can probably hear. That's pretty much got to be my X factor now, I think, because the RF didn't work, as mentioned previously. Yeah, that tilt, the gimbal, I had from a previous project, left over. So that's pretty good. Those servos are from Hobby King. They don't pay me sponsorship, sorry. A little laser there, which is pretty bright for what it draws. It's only like 8 milliamps. Pretty happy with that. Yeah, umbilical cable to the hand controller. It's all done in spiral wrap. Same goes for the cable to the gimbal here. It's spiral wrapped, just, you know, standard servo cables in there. It does have, what are we, 12 batteries all up. That's series parallel. On the PCB, I've got, I don't know if you can see it in there, I've got a couple of regulators. One of them regulates from 9 volt to 6 volt. The other one regulates from 9 volt to 5 volt. I was trying to keep the power supply separate to from the servos and everything else. So I've got very stable voltage regulation going on there. So I'm pretty good. As far as the outputs for the LEDs, I've got a couple of Darlington array or transistor arrays. Those chips there, the PCB ICs in there. They're ULN 2003s. Yeah, so they're just basically buffering the output so that with the LEDs and the buzzer and everything else turns on, it's not drawing a whole lot of current through the microcontroller power supply. It's working pretty well. So yeah, what else I'll tell you about the construction wise, that's just obviously PMMA acrylic glued down together. There's all my test bits to make sure it's all going to fit. Don't know if you make that out there, but it didn't fit. So yeah, not sure if I've already mentioned it. I do have the serial comms sitting just here. They're the jumper cables that go to the other system. I've got them labelled with TX, RX, ground. So it's pretty obvious what they're meant to be. I've also, just in case I needed it, there's the Arduino that's got a little breakout to the USB and power in, just in case I wanted to be able to utilise that. I didn't, but good to have it just in case. This side here you've got that's where the cables come out on this side to the servos. That's the hole for the cables coming out to the hand controller. Over here, that's my little knob to adjust the, oh, can you see that? There you go. That's the knob to adjust the contrast on the LCD. It's trying to keep it fairly flush there so it doesn't get broken off. I've had that problem in the past. You can adjust that. Ta-da! Yeah. All in all, I'm really pleased with the construction of this. Actually, for bonus points, there's a little fuse just there just in case I have a short somewhere. It's 2 amp fuse, I think it is at the moment. Hasn't blown yet, so all good. I will test the power consumption for the report. Because I haven't blown it, I really haven't bothered too much with that. Right, as far as the code goes, I'm not going to bore you with all the details of that. In essence, it's all written in C. I have used mostly some Arduino functions with a couple of my own just to try to limit the interference between all the different libraries. So yeah, I've defined a hell of a lot of stuff there, just so I can adjust stuff very easily if I want to. I know I definitely could have gotten rid of all these global variables. That sickens me. There's so many of them. But, you know, really, I ran out of time. So yeah, setup function, loop function. I've got to fit some stuff if-deft. So just basically this one here, for example, if I've defined Scott servo, then I can use my own little library there. That's what I've written to do the servos. Just, you know, takes a pointer, moves it wherever you want, done deal. I find it interferes with the code a lot less than using the default Arduino library because I hate those things. Yeah, function and it, setup pregame, they all basically interlink pretty well. There's no errors that I can know about in there. I did write my own stuff for the serial. This one here, SER201, that just does the hand controller. Not sure if you can see that there. There you go. Pretty, isn't it? That's as simple as interrupt. Oh, line count wise, there's over 1100 odd lines so far. I might tweak that a little bit later on. We'll see how we go. So yeah, it's a lot of code.